The numbers in this sequence increase by the same amount each time. Write the missing numbers. So we can see that we have 42 and then 49. And we need to spot that 42 plus 7 is 49. Now we know that the numbers in this sequence increase by the same amount each time, so we found that that's an increase of 7 each time. So to find this box here, we have 49 plus 7, so that's 56. And then we can check 56 plus 7 is 63, and 63 plus 7 is 70. But we also need to find this box here. So the number in this box plus 7 has to be 42. So we can solve this by working backwards and subtracting 7 from 42. 42 minus 7 is 35. So that means 35 plus 7 is 42. So 35 is this missing number here. Adam chooses the colours for a new team shirt. The shirt has 2 colours. There are 4 colours to choose from: yellow, blue, white and red. Write the 2 missing combinations. The shirt could be yellow and blue, yellow and white, yellow and red, blue and white, and what else? So the colours are yellow, blue, white and red. So we can write YBWR to represent those colours. So if we start with yellow, we could have yellow blue, yellow white and yellow red. Then from blue, we could have blue white and blue red. Remember, we already have blue yellow because we have yellow blue. Then we can have white red because we already have yellow white and blue white. So those are the possible combinations because we have red paired with all of our other colours, so we have yellow red, blue red and white red. So we have blue and white, but they haven't written blue and red, and we also need white and red as our other possible combination. Here are 4 number cards. We have 2, 3, 4 and 7. Layla uses each card once to make a 4-digit number. She places 4 in the tens column. So we can remember that we count place values from the right, and we have our ones, then our tens, then hundreds, then thousands. So if she places 4 in the tens column, that's 4 as this card here. Then she places 2 so that it has a higher value than any of the other digits. So remember, the value is the place value, and as we move to the left, the place value gets bigger, so the value increases. So that means she must place the 2 in the thousands column, because 2000 will have a greater value, so represent more than any number of hundreds, tens or ones. Then she places the remaining 2 digits so that 7 has the higher value. So that means 7 will go in the hundreds place because the hundreds digit has a larger value than the ones digit. So that means her other card, the 3, has to be placed in the ones. So her number is 2743. Write the 3 missing digits to make this addition correct. So we can solve missing digit addition problems by following the same steps that we use for column addition. So that's working from right to left. So here, starting with our ones column, we have 9 plus something, and we have a 6 as the ones digit of our answer. But if they started with 9, clearly they haven't added to make 6. They must have added to make 16 and then carried the 1. So 9 plus 7 is 16 because 16 minus 9 is 7. So that's this digit here. So now let's move on to our tens column. We have 1 plus something plus 2, so that's 3, and we have a 7 as the tens digit of our answer, and 3 plus 4 is 7 because 7 minus 3 is 4, so this missing digit here is a 4. 1 plus 4 is 5 plus 2 is 7. Then onto our hundreds, we have 2 plus 4, so that's 6 as the hundreds digit of our answer. And now onto our thousands, we have 3 plus 7. That makes 10, so we need to write 10 as 1, 0, so with the first digit above the next place value column along. And that means for the 10,000s, we have 1 plus 5, so that's 6 as the 10,000s digit of our answer. Tick the numbers that are common factors of both 12 and 18. So a factor is like the opposite to a multiple. So a factor of 12 is a number with 12 in its times table, and a factor of 18 is a number that has 18 in its times table. So first we need to think, are the numbers 12 and 18 in the 2 times table? Because we need common factors, so we need numbers that have both 12 and 18 in their times tables. So we can tick the number 2 because 6 times 2 is 12 and 9 times 2 is 18. So 12 and 18 are both in the 2 times table, so we can say that 2 is a common factor of 12 and 18. And we can tick 3 as well, because 12 and 18 are both in the 3 times table. 4 times 3 is 12, and 6 times 3 is 18. So are 12 and 18 in the 6 times table? Well, we can tick 6 as well, because 2 times 6 is 12, and 3 times 6 is 18. So both 12 and 18 are in the 6 times table. But 9 is not a common factor, because 12 is not in the 9 times table. So 9 is a factor of 18, because 2 times 9 is 18, but we can't multiply 9 by any whole number to get 12. So because 9 is not a factor of 12, we can't say that it's a common factor of both 12 and 18. And we can't tick the number 12 either, because 18 is not in the 12 times table. So of course 12 is a factor of 12, because 12 is in the 12 times table, but 18 is not in the 12 times table, so 12 is not a factor of 18. So we can't say that it's a common factor of both 12 and 18, because it's only a factor of 12, not a factor of 18. This chart shows the number of different types of big cat in a zoo. There are 20 big cats in the zoo altogether. Here are some statements about the chart. Tick the statements that are true. So first we have, there are more cheetahs than jaguars. So we can see that the section of the pie chart for cheetahs is this section here, and the section for jaguars this section. So because the section for cheetahs is larger on the chart, we know that it's true. There must be more cheetahs than jaguars because the section of the pie chart is larger. Now, the total number of lions and tigers is 10. So we know that there are 20 big cats altogether. But if we look at the combined section for lions and for tigers, we know that the total will be more than 10 because that's more than half of the pie chart. So if we had 10, that would be half of the pie chart because half of 20 is 10. But because we have more than half, we know that there must be more than 10. So this statement is not true. Now, 1/4 of the big cats are cheetahs. So the section of the pie chart for cheetahs is this section here, and we can see that that is 1/4, so 1 part out of 4 of the chart. So that's true, and we know that's true because we have a little square in the corner, and that shows a right angle. So remember, a right angle is 90 degrees, and when we have angles around a point, like we do on a pie chart, that's a total of 360 degrees. So because 90 is 1/4 of 360, 360 divided by 4 is 90. If we have a right angle on a pie chart, then we know that that's 1/4. Now, our last statement says there are more than 5 jaguars. So we know that there are 20 big cats altogether, and 5 is 1/4 of 20. 20 divided by 4 is 5, but we can see that the section for jaguars on the pie chart is less than 1/4. So the number of jaguars will have to be less than 1/4 of 20, so less than 5, not more than 5, so this statement is not true. A farmer is packing eggs. Each box holds 6 eggs. The farmer has 980 eggs to pack. How many boxes can the farmer fill using 980 eggs? So here we need to divide 980 by 6. And we know that we need to use division here because they've told us the total number and they've told us the number in each thing or one thing, and we need to know how many things, so how many boxes. So we need to divide 980 by 6, so 9 divided by 6 is 1, remainder 3, 38 divided by 6 is 6, remainder 2, and 20 divided by 6 is 3, remainder 2. So that means the farmer can make 163 full boxes, and then the remainder 2 will be 2 eggs that don't get put in a box. So that means that 2 eggs will be left over. Jack has £400. He spends 35% of his money on a new bike. How much does Jack spend on his new bike? So he spends 35% of his money and he has £400. So we need to find 35% of £400. Remember, a percentage is really a fraction which has a denominator of 100. And we know that to find a fraction of a number, we can divide by the denominator and then multiply by the numerator. So we can start by dividing 400 by the denominator. So 400 divided by 100 is 4, because remember, we can cancel our end zeros, and then we have 4 divided by 1. So that's 4. Then we need to take that answer and multiply by the numerator. So work out 4 times 35, and that gives us 140. So Jack spends £140. The other way to find 35% would be to find 10%, and we find 10% by dividing by 10, because 10 tens make 100. So 400 divided by 10 is 40, and if 10% is 40, we can find 30% by multiplying 40 by 3. So that's 120. So 10 times 3 is 30, 40 times 3 is 120. But we don't want 30%, we want 35%. So how can we find 5%? Well, if we know that 10% is 40, because 5 is half of 10, we can find half of 40, so that's 20. So putting together 30% and 5% will give us 35%, so that's 120 plus 20, so we get the same answer, 140. The Angel of the North is a large statue in England. It is 20 metres tall and 54 metres wide. Ali makes a scale model of the Angel of the North. Her model is 40 centimetres tall. How wide is her model? So we know that the actual statue is 20 metres tall and 54 metres wide. But her model is 40 centimetres tall. So how can we get to 40 centimetres from 20 metres? And remember, because we're scaling, we'll either need to use multiplication or division. Well, 20 times 2 is 40, so that would give us 40 metres, and then we could divide by 100 to change metres into centimetres. So 54 times 2 is 108, so that will be 108 centimetres wide. Layla draws a square on this coordinate grid. 3 of the vertices are marked. What are the coordinates of the missing vertex? So we can see that to get from this vertex, or this point, to this point here, we go down 4 and then 4 to the left. So if we do the same from this point, so go down 4 and then 4 to the left, that tells us that our missing vertex will be at this point here. And with coordinates, we can remember that we always write the x coordinate first. So if we go down, we can see that the x coordinate will be -3, and then if we go across, we can see that the y coordinate is 1. So the coordinates of the missing vertex are -3, 1, because we can see that if we join these points, we make a square. Now the other thing that we could do to find where the missing vertex will be is to turn our page so that we have these 2 points lined up horizontally. Then it's far easier to see that to make a square, we'll need the coordinates at this point here. So that's -3 on the x-axis and 1 on the y-axis. Stefan has 600 millilitres of water in a bottle. He pours some of the water into 2 measuring jugs as shown. How many millilitres of water are left in Stefan's bottle? So in this jug, we can see that he pours between 100 and 200 millilitres, so that's 150, because half of 100 is 50. And here we can see that this point on the scale between 100 and 200 will be 150, but he pours between 150 and 200. So half of 50 is 25, so that's half of the difference, which means that after 100 we will have 125, then 150, so the point where the water is will be 175 millilitres. So we know that he's poured 150 millilitres into this container and 175 into this one. So we can add those to work out that he's poured out 325 millilitres altogether. But we want to know how many millilitres of water are left. So we need to subtract what he's poured out from the 600 that he started with. So we can work out 600 minus 325. And using column subtraction, that gives us 275 millilitres of water that are left in the bottle. This table shows the areas of the United Kingdom and Jamaica. The area of the United Kingdom is larger than the area of Jamaica. How many times larger is the United Kingdom? So we can see that the area of Jamaica is 10,000 square kilometres and the area of the United Kingdom 240,000. So we need to think 10,000 times what is 240,000? Well, 10,000 times 24 is 240,000 because 1 times 24 is 24, and then if we have 4 end zeros in a multiplication question, we need 4 end zeros in our answer. So that means the United Kingdom is 24 times larger. The other way to work that out would be to divide 240,000 by 10,000. So remember, when we have division problems with end zeros, we can cancel them, and so 24 divided by 1 is 24. So that's 24 times larger. A box contains 2.6 kilograms of washing powder. Jack uses 65 grams of powder for each wash. He uses all the powder. How many washes did Jack do? So 2.6 kilograms is 2,600 grams because there are 1,000 grams in a kilogram. Now if we have an amount of kilograms that's a decimal, so here we have 2.6, to change that to grams, so to multiply by 1,000, what we can do is put zeros on the end so that we have 3 digits after the decimal point, and then we can just take out the decimal point and we have the number of grams. So we know that there are 2,600 grams of powder altogether, and he uses 65 for each wash. So to find the number of washes, we need to divide 2,600 by 65. Now we could use long division for this, or we could count up in steps of 65 until we get to 2,600. So if we know that one wash uses 65 grams, that means 2 washes will use 130, because 65 times 2, or 65 plus 65, is 130. And that means to find the number of washes that use 1,300 grams, we can multiply by 10, so that's 20 washes. Now, to get to 2,600 from 1,300, we can double or multiply by 2. So 1,300 times 2 is 2,600, and 20 times 2 is 40. So that means that 40 washes uses 2,600 grams, so Jack did 40 washes. 2 of the angles in a triangle are 70 degrees and 40 degrees. Jack says the triangle is equilateral. Explain why Jack is not correct. So here we need to remember that an equilateral triangle is a triangle where all the sides are the same length and all the angles are the same size. So Jack is not correct because the angles in an equilateral triangle are always the same, and they're always 60 degrees because we have 180 degrees in a triangle, and if they're all the same, we can divide 180 by 3, and that gives us 60. So the angles in an equilateral triangle are all 60 degrees, so they can't be 70 degrees or 40 degrees. A shop prints designs on t-shirts. They use this formula to work out the price for printing a design. Price equals 60 pence times number of colours plus £1.25. What is the price for printing a design that has 3 colours in it? So to find the price, we multiply 60 pence by the number of colours. So if that's 3, we multiply by 3, and then we need to add £1.25. So 60 pence times 3 is 180 pence, so that's £1.80. But then we need to add £1.25 to that to find the total price. So that gives us £3.05 as our price for a design with 3 colours. Now, Amina has £5 to spend on printing a design. What is the greatest number of colours she can have in the design? Well, we can subtract £1.25 from £5, and that gives us £3.75. So she has £3.75 to spend on colours, and we know that colours are 60p each. So one colour is 60p. If we double, 2 colours will be £1.20 because 60p times 2 is 120p or £1.20. If we double again, 4 colours will be £2.40, so that's £1.20 times 2. 6 colours we can get by adding the cost of 2 colours and the cost of 4 colours, and £1.20 plus £2.40 is £3.60. So we're very close to £3.75. So if she bought 7 colours, that would be too expensive, because £3.60 plus another 60p would take her to £4.20. But she only has £3.75 to spend on colours, because she'll need to add £1.25. So if it's more than £3.75, when she adds the £1.25, that would be more than £5, and she only has £5 to spend. So that means the greatest number of colours she can have is 6 colours, because that will cost her £3.60, and then when she adds the £1.25, it will still come to less than £5. Whereas if she had 7 colours, adding the £1.25 would take her over £5, and she only has £5 to spend, so she wouldn't be able to afford a design with 7 colours. A book has 276 pages. Amina has read 1/3 of the book. How many pages are left for Amina to read? So first we can find how many pages she's already read, and then subtract that from the total number of pages in the book to find how many pages are left. So to find 1/3 of 276, we can divide by 3, so divide by the denominator. And because the numerator is 1, we don't need to multiply our answer by anything. We have 92 pages that she's read. So because the book has 276 pages, we can find the difference and subtract the pages that she's read from that. And 276 minus 92 is 184. So that's how many pages are left for Amina to read. The other thing we could do is to realise that if she's read 1/3, then she hasn't read 2/3. So we could find 2/3 of 276. So to find 2/3, we would still divide by 3 to get 92, but then we would multiply that by the numerator. So if we have 2/3, our numerator is 2, and that gives us the same answer. We could also represent this problem with a bar model. So there are 276 pages in the book, and if she's read 1/3, she's read 1 part out of 3. So the other 2 parts out of 3 are what she has left to read. So we can find that 1/3 of 276, or 276 divided by 3, is 92, and that means we have 92 plus 92, so that's 184 pages left to read. On a dice, the sum of the dots on opposite faces is always 7. Draw dots on the 3 empty faces of the net so that it could fold up to make a dice. So opposite faces, remember, can't be next to each other. So for example, the opposite to the face that's on the top of the dice will be the face that's on the bottom. and opposite faces, the dots need to total 7. So here we have a 6, so on the opposite face we'll have 1. But the opposite face can't be this face here, or this face here, because these faces are not opposite, they're next to the 6. We can see clearly that this face is next to the 6, and this face will be next to the 6 as well, because when the net folds to make a dice, these edges will join. So that means if we have 6 on this face, we'll need to have the 1 on this face here. And now here we have a 4, and 4 plus 3 is 7. But again, we can't have the 3 next to the 4, because we need to have the dots making 7 on opposite faces. So two faces that are next to each other can't be opposite, so that means the 3 will need to be on this face here, because when we fold to make the dice, this face will be opposite to this face. And that means we need to have 5 here, because that's the only number on the dice that we've not used, and 5 and 2 make 7, so when the net folds up, this face will be opposite to this face here. This is a diagram of a vegetable garden. It shows the fractions of the garden planted with potatoes and cabbages. The remaining area is planted with carrots. What fraction of the garden is planted with carrots? So we know that 2/3 is potatoes and 1/4 is cabbages. So what we can do is add up the total area of the garden that's planted with either potatoes or cabbages. So add 2/3 and 1/4, and then we can subtract that total from 1/2 to find the fraction that's carrots. Because remember, the whole garden will be 1/2, so all of the fractions will need to add up to 1. So we can't add 2/3 and 1/4 without finding equivalent fractions first. 3 and 4 are both factors of 12, so we can change 2/3 into 8/12 and 1/4 into 3/12. So 8/12 plus 3/12 is 11/12. And that's the fraction of the garden that is either potatoes or cabbages. So 2/3 plus 1/4 is 11/12. And what we can do to find the fraction that's carrots is subtract 11/12 from 1/2. And remember, 1/2 can be written as 12/12, because if we have a fraction with the same numerator and denominator, we have 1/2. So 12/12 minus 11/12 is 1/12, and that's the fraction of the garden that must be carrots, because 2/3 plus 1/4 plus 1/12 will add up to 1/2. We know that 2/3 plus 1/4 is 11/12, and if we add another 12th, so 1/12 for carrots, that will give us 12/12, so that will be the whole of the garden. 33,630 equals 354 times 95. Use this multiplication to complete the calculations below. So we have 354 times 9.5. So here we need to spot that 9.5 is the same as 95 divided by 10. And if you divide one of the numbers in a multiplication by 10, you can divide the answer by 10 as well. So 33,630 divided by 10 is 3,363. Because if a number ends in a 0 and it's a whole number, to divide by 10, we can just take off the 0. Now we have 3,540 times 95. So here we need to spot that 354 times 10 is 3,540, because if you multiply a whole number by 10, you put a 0 on the end. And if we've made one of the numbers in our multiplication question 10 times bigger, then the answer will be 10 times bigger as well. So we need to multiply 33,630 by 10. And that gives us 336,300. Because again, to multiply a whole number by 10, we can put a 0 on the end. But now we have a division problem. So we have 3,363 divided by 95. Now it's a good idea to write out next to this multiplication fact what division fact we can get from it. So if we know 354 times 95 is 33,630, then we also know that 33,630 divided by 95 will be 354, because if you divide the answer by one of the numbers in a multiplication, you get the other number. But we don't have 33,630, we have 3,363. So that's what we get by dividing this number by 10. So if the dividend is 10 times smaller, then the answer will be 10 times smaller as well. So we need to divide 354 by 10. Remember, an easy way to divide a whole number by 10 is to imagine the decimal point on the end and move it one place to the left. So that's 35.4. That's what we get when we divide 354 by 10. So with division, if you divide the number that you start with by 10, or if the number is 10 times smaller, then the answer will be 10 times smaller as well. Or you can divide the answer by 10 as well. In March, Ken collects 2, 3 or 4 eggs each day from his hens. In the first 20 days, Ken collects 57 eggs altogether. There are 31 days in March. What is the greatest number of eggs Ken can collect in March? So we know the total for 20 days, but there are 31 days in March, and 20 plus 11 is 31. So that means he has 11 days of egg collecting left. Now we know that he's already collected 57 eggs, and he's got 11 more days. And we want the greatest number. So the greatest number of eggs that he can collect each day is 4. So we can multiply 11 days by 4 eggs. So that means 44 more eggs can still be collected. So to work out the greatest number of eggs he can collect, we can add 57, so the number that he's already collected, and 44, because that's the largest number of eggs he can still collect, because he's got 11 days left and he can collect at most 4 eggs each day, so 11 times 4, 44. So that means he can collect at most 101 eggs in March. Jack finished a sponsored run in 53 minutes 25 seconds. Ali finished 3 minutes 50 seconds after Jack. How long did Ali take? So if Ali finished after Jack, that means that he took longer. So we need to add 3 minutes and 50 seconds to 53 minutes and 25 seconds. And we can do that using a timeline, because remember, column method will not work for time. So if we're on 53 minutes 25 seconds, we can add 3 minutes, and that will take us to 56 minutes and 25 seconds. So now we need to add another 50 seconds. We're on 25 seconds, so we can think how many more seconds will take us to the next minute. Well, there are 60 seconds in 1 minute, so if we add 35 to 25, that will give us 60, and so take us to the next minute. So take us to 57 minutes. But that's adding 35 seconds, and we want to add 50. So we need to add 15 more seconds, because if we add 35 and then 15, that's adding a total of 50. So 57 minutes plus 15 seconds is 57 minutes and 15 seconds. The other way to add 3 minutes and 50 seconds would be to spot that this is just 10 seconds less than 4 minutes. So from 53 minutes and 25, we could add 4 minutes and then subtract 10 seconds, because 3 minutes 50 is 10 seconds less than 4 minutes. So adding 4 minutes gives us 57.25, and then subtracting 10 seconds gives us 57.15, so gives us our answer. Now, Layla finished the run 8 minutes 45 seconds before Jack. How long did Layla take? So if she finished before Jack, that means she finished in less time. So this time we need to subtract. Again, we can draw a timeline, and we have 53 minutes 25 as the time that Jack finished. So then we can subtract 8 minutes, and 53 minus 8 is 45. So that takes us to 45 minutes 25 seconds, and now we need to subtract 45 seconds. To do that, we can first subtract the 25 seconds that we have, so that will take us back to 45 minutes, and then because we need to subtract 45 and we've already subtracted 25, we need to subtract another 20 seconds. So remember, there are 60 seconds in a minute, and 60 minus 20 is 40. So that gives us 44 minutes and 40 seconds. Again, we could spot that 8 minutes 45 seconds is just 15 seconds less than 9 minutes. So from Jack's time, we could subtract 9 minutes, but that would be subtracting 15 seconds too much. So then we could adjust by adding 15 seconds. So 53 minus 9 is 44, but then we need to adjust by adding 15 seconds, and 25 plus 15 is 40, so again we get the same answer, 44 minutes and 40 seconds.